Hi, good morning. I'm Swapnil Varma, and I'll be taking a session with you, the topic of computer science in IB board. I believe you're from IB board, right? So I selected a topic from your textbook, which is topic number 4, computational thinking. This chapter is coming from your textbook, and we will be studying the important key concepts in this chapter. One of them involves algorithm, flowchart, which is an interrelated concept in algorithm, and an example of a pseudocode expression, which teaches us how to write an algorithm into a pseudocode. I chose this topic because it is one of the key concepts in your syllabus. So let's proceed and have a look at what all we can study in this chapter. Okay, so I believe that you might have heard the term algorithm before, and this is not a new concept for you. However, I'd like to share a simple example with you. For example, I want to make a Maggi dish, and I want to make sure that I complete making this dish in a successful manner. So I need to follow certain steps in a certain defined sequence, and it is only then I can achieve what I want to. So for example, first I need to take a pan. I need to put the required amount of water, say 1 cup or 2 cups, and I need to boil it first. Then I need to add the noodles and then the masala into that. I cannot just change the order of the steps. I need to make sure that the steps I follow are in that same manner. So such a methodology where I have to follow certain instructions in a particular sequence is nothing but an algorithm. So when you are performing any actions or trying to solve any real-time problems with the help of a computer, you require an algorithm. And what exactly does this algorithm does is, it is a series of unambiguous instructions designed in an order to solve the problem, and not only to solve the problem, but to it is also necessary to achieve a certain goal in a finite number of steps. Okay, so that is more important, that whatever the problem I'm trying to solve over here, or a certain goal that I'm trying to achieve, has to be done in a finite number of steps, which follows a certain sequence. Now, what are the special characteristics of an algorithm? It involves finiteness, definiteness, input, output, and effectiveness. All these factors are the ones which are contributing in the efficiency of an algorithm. So the algorithm should terminate after a finite number of steps. I cannot expect that the algorithm keeps on going for 1,000, 10,000, lakhs. No, I cannot. I should assure that it should be finite. There should be some definiteness, that it should be precisely defined. Whatever number of steps I'm writing, it should be quite clear. Yeah, I should be specifying the inputs I'm going to use in my algorithm, or the specific number of inputs that I'm using in my steps. A final output, yeah, and effectiveness that needs to be performed in the algorithm should be there. So all the operations to be performed in the algorithm must be sufficiently basic, that they can be in principle done exactly in the finite length of time by man using pen and pencil, which basically means the more you reduce, the lesser the number of steps you have, the more effective your output can be, most probably. Why? Because you cannot have a algorithm with, say, 10,000 lines. It becomes more difficult and complex to process, right? So we have a simple, again, we have an example of a boiling egg in your textbook, and making omelette, which exactly follows a certain number of steps and shows you how you can make a boiling egg or an omelette in a particular sequence. Now we have certain keywords which are associated with an algorithm. First is simple English, that you need to use simple and direct words and not ambiguous words so that your algorithm is absolutely clear. Again, we have something called as a flow chart, which is a pictorial representation or a graphical representation of your algorithm. So you can also make the steps into a pictorial representation. Why we need to do that? Because it helps to make our problem understanding capabilities more effective. You can understand the problem and you can understand your steps more effectively once you see it in a graphical format, right? Another keyword that is involved with your algorithm is a pseudocode, which we will see in future that how important it is along with the algorithm. And our chapter and our syllabus and the topics involved over here revolve a lot around the pseudocode and algorithm. So what is a pseudocode? It's a generic artificial language that describes computer algorithm but does not use the syntax of a particular programming language. Okay, so it's not having a proper syntax or a rules that you use in your coding language, but it is simple language, your natural language, which will help you to develop your algorithm. Yeah, it's like a supporting language which will help you to develop your algorithm, and we will see in future that how it is being used with the help of an example. And finally, we have the most important part is a programming language. So once you're done with your algorithm, your pseudocode, you are ready to do your final coding or programming on your computer, and you can use this coding in order to generate your output, which will help you to solve any problem of yours. Okay, so let us have a quick look at the important keywords. As we already discussed, we studied about flowcharts, where we had these pictorial representations, symbols, which we can use to design an algorithm in a graphical format. Input, if, while statements, start, end, connector, and these symbols are the prototypes. You need to use them exactly the way they have been mentioned. Yeah. Now, coming to the concept of the pseudocode, which is the last but the most important concept here in this lecture. The main purpose of pseudocode is to help the programmers develop computer programs, and it is written for humans. The syntax used is not as strict as the one used in computer language. And pseudocode normally omits details that are not important for human understanding for the algorithm. So again, as I've already mentioned, pseudocode is basically written before you write your algorithm, and it is done in a manner that you can use very simple keywords in your own natural language instead of using the commands. And once you have used this simple natural language, you can actually understand it more easily, and then you can convert it into your algorithm. So that makes your life more easier when using an algorithm. However, we need to know one thing: this is only for human convenience, and it cannot be applied into the computer machine, because the computer machine cannot interpret a pseudocode. Yeah, because you're not actually using the keywords of any programming language. You're using your own language, and computer does not understand the human language. It understands the programming or coding language. So here the important point, that computers can't interpret the solution in the pseudocode, and that it should be converted into a computer language. So when a programmer develops a pseudocode, he does not necessarily think of the computer language, and it can be done later on. Now, let us have a look at this example, which will give us a complete overview of what we studied altogether. So algorithm, let us have a look at how it looks. So I'm starting algorithm. I would say begin, display the message, and in double quotes, this will be printed twice, double quotes close 2 times, and display the message. This message will be printed 4 times end. Now, I basically have a simple algorithm where I want to print this particular message and this particular message, which is in double quotes, I want to make sure that it is printed 2 times. Yeah, that's what it says. print 2 times. And the second message, I want it to be printed 4 times. So how can I do it? Let's try to understand how can we convert it into a pseudocode. So loop A, yeah. So we begin with any particular alphabet of your choice. You can just, because as we've already studied, pseudocode is like using a natural language. You can use terms convenient to you. So it's not necessary that you need to mention loop A. You can say anything, loop X, loop Y, whatever. So loop A from 1 to 2. So can you tell me why we have mentioned 1 to 2? Because we already observed that it wants us to display this message 2 times. So loop A from 1 to 2, output this will be printed twice. End loop. Then the next message we want is, we wanted to print it 4 times. How can we do that? We need to initialize something, a variable called as C, something called as a variable C, and 1, and loop while. So we are using something called as the while commands, and we'll be studying that in future, that what exactly are while commands. So basically, as of now, we can understand that it's a condition. And why do we need this condition? Because we want to print this message 4 times. So as long as C is less than 5, then the output, this message will be 4 times. And C is equal to C plus 1. So this incrementing will increment my loop every time. So the first time I will check that if C is 1, then while C is less than 5. So 1 is less than 5. Yes, it is less than 5. So the message would be printed. And the next time the loop would be incremented 1 time plus 1 time. Okay. So then it would again check the loop. This time, if I am going to check, the value of C would have been incremented to 2. Why? Because here I told that C is equal to nothing but C plus 1. So my initial value was 1 and I incremented it with 1, so it became 2. So this time C becomes 2. And now I check my loop whether 2 is less than 5. Yes, the message is printed. And this will go on as long as the value is less than 5, which is 4. And finally, the message would be printed 4 times and the loop would come to an end. Yeah. So this is a simple example of how the algorithm can be converted into a pseudocode using some simple human languages and some simple coding concepts. Not exactly the coding commands, but the coding concepts are essential. Yeah. So this is all about algorithm and flowcharts and pseudocode. I hope you like the session. Thanks a lot.